This is section 3.5 on implicit differentiation. So the homework is 1 to 33 odd, 49 to 52 all, 54, 56, and 57. Let me show you the homework. So page 215, and we have to go up to problem 57, it looks like. Cool. Page 216. And there we go. Okay. All right, so implicit differentiation. I suppose I want the derivative of f of x cubed dx. Well, from the chain root, it would be 3 times f of x squared times f prime of x. Or we can assume that y is a function of x implicitly. We just call this y. Okay, so the derivative of y cubed with respect to x, if y is f of x, then just put a y there and a y prime there, 3y squared y prime, or 3y squared dy dx. Implicit differentiation, you don't have y explicitly as a function of x. You've got x's and y's mixed up. Maybe you can solve for y, maybe you can't. Normally we won't bother. We will just say, okay, there is a function behind the scene, so to speak. Okay, if we pretend it's like f of x cubed, so we say 3 times f of x squared times f prime of x, we're going to go, the derivative of y cubed is 3y squared dy dx. Okay, bottom line, if you differentiate and there's a y involved, you have to treat it implicitly as a function of x, and you have to multiply by dy dx by the chain rule. Okay. So, number one, 9x squared minus y squared equals 1. We're not going to try to solve for y. In fact, you can't easily without a plus or minus. What you do is differentiate both sides with respect to x. So derivative of this is 18x. Derivative of this is minus 2y times dy dx equals 0. Okay, so for this implicit differentiation stuff, if there's a y and you're differentiating, you have to multiply by dy dx by the chain root. If there's an x, just take the normal derivative. Now algebraically solve for dy dx. Move that over. 18x equals 2y dy dx divided by 2y. So dy dx is equal to 9x over y. And this is our first instance where our derivatives will have x and y, perhaps. Before, when we had explicit differentiation, it basically was just only x, but now you could have x and y. Okay, so the idea is you can't solve for y, or maybe it's too difficult, don't even bother. Just pretend y is a function of x. Here's x squared minus 4xy plus y squared equals 4. So you differentiate both sides with respect to x. 2x. This one is a product root, treated as negative 4x times y. So first function, negative 4x, times derivative of the second, derivative of y is 1 dy dx, because there's a y involved, plus second function, y, times derivative of the first, derivative of negative 4x is negative 4, plus derivative of y squared is 2y dy dx, equals the derivative of the right side is 0. Okay, now solve for dy dx. That means all the dy dx's are on one side, everything else on the other side. So I will leave the dy dx's here. I'll throw over the negative 4y, and I'll throw over the 2x. So these two both have a dy dx. So I'm going to factor out the dy dx. I will have a negative 4x plus 2y equals, that goes over negative 2x plus 4y. Divide both sides by negative 4x plus 2y. So dy dx is 4y minus 2x over 2y minus 4x. You can leave it like that, although you could factor out the 2 to keep going. Okay, 11, y cosine x equals x squared plus y squared. Don't try to solve for y, it's actually impossible here, but you can differentiate implicitly. Okay, so if you differentiate where there's a y involved, pretend it's some function of x. Okay, so there's going to be a chain root. We will multiply by dy dx. If x is involved, just do the regular derivative. So product root, first times derivative of the second, derivative of cosine x is negative sine x, plus cosine x times derivative of the first, derivative of y is 1 dy dx, equals 2x. There's an x, so don't do anything extra. But y squared, you need 2y times dy dx. And then algebraically, all the dy dx is together, all the non-dy dx is together. So I'll subtract 2y dy dx. I'll add this expression. So the right side has 2x plus y sine x. The left-hand side, I factor out the dy dx and I have cosine x minus 2y. Divide both sides by this factor. So dy dx is 2x plus y sine x over cosine x minus 2y. Okay. Question number 9, x squared over x plus y equals y squared plus 1. Now, you could do the quotient root. There's a sneaky way to get around it, is to multiply both sides by x plus y. Yes, you have a product, but at least I don't have to do the quotient root. Quotient root is one of my least favorite. Okay, so multiplied by x plus y, I have x plus y times y squared plus 1. FOIL this out. X squared equals xy squared plus x plus y cubed plus y. Now I differentiate both sides with respect to x. Remember, y cubed, pretend it's like f of x cubed. The derivative will be 3 f of x squared f prime of x. So I'm going to write 3y squared dy dx. Okay. So I differentiate both sides with respect to x. This becomes 2x. This is a product rule. First times derivative of the second, x times 2y dy dx, plus y squared times derivative of the first is 1, plus 1, plus 3y squared dy dx, plus 1 dy dx. Okay, so I have all the dy dx's on one side, which means I'll bring this over, subtract the 1 over. So this side has 2x plus, y squared moves over, it becomes minus y squared and a minus 1. And this side, the dy dx's are 2xy plus 3y squared plus 1. Now just divide both sides by 2xy plus 3y squared plus 1. And here's my dy dx, 2x minus y squared minus 1 over 2xy plus 3y squared plus 1. Okay, 7. X to the fourth plus x squared plus y cubed equals 5. So don't try to solve for y. It's difficult or impossible. Just do this implicit differentiation stuff. Okay, derivative of that is 4x cubed. This is a product. So first x squared times the derivative of the second derivative of y squared is 2y. And since there's a y, you have to tack on a dy dx. Plus second function y squared times the derivative of the first. Derivative of x squared is 2x. Don't need anything else because there's an x involved. Plus 3y squared, and since it's a y, dy dx equals the derivative of the right-hand side, which is just 0. Okay, so dy dx is stay. That one moves over, it becomes a negative. That one moves over, it becomes a negative. Factor out the dy dx, so 2x squared y plus 3y squared equals all that. Divide both sides by this. So dy dx is negative 4x cubed minus 2xy squared over 2x squared y plus 3y squared. Okay, back to problem number 3. Square root of x plus square root of y equals 1. That's x to the half plus y to the half. Okay, so differentiate with respect to x. 1/2 x to negative a half. Differentiate with respect to y. 1/2 y to negative a half dy dx, because there's a y involved, and derivative 1 is 0. And just to make this look nicer, multiply both sides by 2 to clear up the fractions. X to negative a half plus y to negative half dy dx equals 0. Move over to x to negative half, it becomes a negative. Divide by y to negative a half. So dy dx is negative x to the half over y to negative half. Flip them both. This negative comes down. This negative comes up. So negative square root of y over x is the final answer. Okay, 21, to give me all this information, f of 1 is equal to 2. Find dy dx, or f prime. Okay, so f prime of x is first times derivative of the second, x squared times 3 f of x squared times f prime of x, plus second times derivative of the first, so f of x cubed times 2x. And that's equal to the derivative of the right-hand side, which is 0. Then I plug in 1, put a 1 there, 1 there, 1 there, 1 there, 1 there. It looks like this. So f prime of 1 plus 1 times 3, f of 1 is 2. So 2 squared f prime of 1 plus f of 1 cubed is 2 cubed times 2 equals 0. Okay. So this comes out to be 3 times 4, which is 12, f prime of 1 plus 16 equals 0. f prime of 1 plus 12, f prime of 1 is 13, f prime of 1, a little bit of algebra, f prime of 1 is negative 16/13. All right, then the inverse trig functions, I'll talk about very quickly. How to get the derivative of inverse trig functions now. Okay, y equals inverse sine of x. Rewrite it as sine y equals x. Then I differentiate implicitly. Cosine y dy dx equals 1. Dy dx is 1 divided by cosine y. Okay. And we could draw a triangle to show cosine y is the square root of 1 minus sine squared of y, which is radical 1 minus x squared. Okay, so bottom line, derivative of inverse sine is 1 over radical 1 minus x squared. We do something similar for inverse cosine. Let me go over the derivation of the derivative of inverse tangent. Y equals inverse tangent of x means tan y equals x. Differentiate implicitly, derivative tangent is secant squared y dy dx equals 1. Dy dx is 1 over secant squared y. Secant squared is 1 over tangent squared. That's 1 plus tangent squared, 1 plus tangent squared y. But we're given tangent of y is x, so 1 over 1 plus x squared. So the derivative with respect to x of inverse tangent is 1 over 1 plus x squared. Okay. So what you want to put on your next cheat sheet are these three. Don't worry about these. Maybe I'll just cover it up. There's nothing wrong with them. They're true, but you almost never use them. Okay, so I want you to know the derivative of inverse sine, inverse cosine, and inverse tangent. These two are almost identical. Derivative of inverse sine, 1 over radical 1 minus x squared. Inverse cosine, negative, the same thing, negative 1 over radical 1 minus x squared. Derivative of inverse tangent is 1 over 1 plus x squared. So there's a lot of similarity here. Again, these three, don't even worry about them. We're not going to use them at all. Okay. So the problems at the very end involve derivatives of inverse trig functions. Here's 17. Inverse tangent of x squared y equals x plus xy squared. So the derivative of this is 1 over 1 plus x squared y squared times the derivative of the inside, which is a product. So first x squared times the derivative of the second, derivative of y is 1 dy dx, plus second y times derivative of first, 2x. Equals derivative of this is 1, derivative of this, well, product root, first x times derivative of the second, 2y dy dx, plus the second y squared times the derivative of the first, which is 1. Okay, then what happened? I slide all of that over. So I have x squared over 1 plus x to the fourth y squared dy dx plus 2xy over 1 plus x to the fourth y squared equals all this stuff. Okay, so I want all the dy dx's together. So move this over. The non-dy dx's go together. So dy dx times x squared over 1 plus x to the fourth y squared minus 2xy equals 1 plus y squared minus 2xy over 1 plus x to the fourth y squared. So for dy dx, I get this thing very messy. It's that divided by that. So 1 plus y squared minus 2xy over 1 plus x to the fourth y squared, all over x squared divided by 1 plus x to the fourth y squared minus 2xy. Okay, that's basically it. You can clean it up a little by multiplying top and bottom by 1 plus x to the fourth y squared. Okay, so if you do that the right way, you get some other stuff, but it's almost like not even worth doing it because you just get something messy. So I'll let you leave it like so. That'd be good enough for me. Okay, so again, a quick reminder, derivative inverse tangent, 1 over 1 plus x squared is what we have over there. Okay. Let's see, do I want to go any farther? Okay. Okay, sine xy equals cosine x plus y. Derivative of this is cosine xy times derivative of the inside, which is a product. First times derivative of the second, plus second times derivative of the first, derivative of x is 1, equals negative sine x plus y times derivative of the inside with respect to x, so it's 1 plus dy dx. Okay, distribute s cosine xy times that plus y cos xy equals negative sine x plus y times negative sine x plus y dy dx. So I distribute it. Okay, then all the dy dx is together. So that one goes together with that one. That one moves over. So dy dx is x cosine of xy plus sine of x plus y equals negative sine x plus y minus y cosine x y. Divide both sides by this mess and you have it. So dy dx is negative sine x plus y minus y cosine of xy divided by x cos xy plus sine of xy. Okay, that's a mouthful here. All right, then we can talk about the equation of the tangent to a curve at any given point, right? So x squared plus xy minus y squared equals 1 at the point 2, 1. So differentiate implicitly 2x plus first times root of the second plus second times root of the first, right? So negative x dy dx plus y times negative 1, negative 2y dy dx equals 0. Parentheses here. So 2x. Oh, yeah, we already got this. All right, so what does this come out to be? 4 minus 2 dy dx minus 1 plus 2 dy dx equals 0. Cleaning this up. So these two combine to give me a negative 4. 3 minus 4 dy dx equals 0. A little bit of algebra. Dy dx is equal to 3/4. And put it in point slope form. Y minus 1 equals m x minus x1. 33, equation of tangent at 1, 2. So differentiate implicitly. 2y dy dx equals 20x cubed minus 20x. Okay. So dy dx is this divided by 2y. 20x cubed minus 2x divided by 2y. Plug in 1. This is 20 minus 2. This is 2 times 2, or 4. So 18 over 4, or 9 over 2. So the equation of the tangent is y minus 2, point x1, y1, right? Y minus 2 equals 9 halves x minus 1. Okay, and I gave you my derivation of the inverse trig derivatives. Okay, so you can look it over or not. It's pretty much the same as what I had in the book. So derivative inverse sine is 1 over radical 1 minus x squared. Inverse cosine is the same thing except there's a minus. Inverse tangent is going to be 1 over 1 plus x squared. Okay, here's a little mini proof of the derivative of cosine and a little mini proof of the derivative of the tangent. Okay, so if you're interested, you can see me about it. Okay, so find some derivatives. Y equals inverse tangent of x squared. So you go 1 over 1 plus this thing squared, x squared squared, times the derivative of the inside, which is 2x. Final answer is 2x over 1 plus x to the fourth. Okay, arc cosine of radical x means the same thing as inverse cosine. So derivative, 1 negative 1 over radical 1 minus the argument squared. So radical x squared just becomes x. And there was a minus in front of the whole thing, and do cosine. And then by the chain root times the derivative of the inside, which is 1/2 x to the minus 1/2. Clean it up, negative 1 over 2 radical x radical 1 minus x, which is the same thing as negative 1 over 2 radical x minus x squared. Okay. And 57. X inverse sine of x plus radical 1 minus x squared. Product root. First times derivative of the second. X times 1 over radical 1 minus x squared. Plus second inverse sine times derivative of the first, which is just 1. And then derivative of this is blah, blah, blah to the 1/2, right? So 1/2, 1 minus x squared to negative 1/2 times negative 2x. 2's cancel out. So what do we have now? We have x over radical 1 minus x squared minus x over radical 1 minus x squared plus the inverse sine of x. So that stuff cancels all this stuff. So the final answer is just inverse sine of x. Okay. All right, just double check I got everything here. But otherwise, I think that's about it. Yeah, okay. So that was section 3.5.